welcome to Data Week Online 2021. Please feel free to introduce yourself in the chat as well, just as we get started. It would be great to hear from some of you in there. Right, well, thank you for everyone for joining, and welcome to this Data Week Online 2021 training session on Introduction to Shiny App Building in R with Mango Solutions. Just a little bit of admin before we start. Just to note that this session is being recorded. Please can everyone ensure that they've read through the JGI Code of Conduct and Virtual Event Policy. My colleague Elaine from the Jean Golding Institute will be sharing the link she just has in the chat right now. Please, for the comfort of everyone else on the call, could you make sure that you mute your microphone? There might be points where the trainers today ask you to unmute as well, but just if that doesn't happen, please make sure you're muted. Please type any questions you've got in the chat box, and they'll be taking you through the process for asking questions as well later on. But also, as well, take the opportunity now to introduce yourself to the other attendees in the chat box. It would be great to hear from some of you. And my colleague Elaine is also going to post a very short 2-question registration form, just so we know who is here on the call today. It would be really much appreciated if you could just fill that in quickly now. It will only take just a couple of seconds, and you can listen to me doing the rest of the intro when you do that. Just a little bit of background to the Jean Golding Institute. We are the central hub for data science and data intensive research at the University of Bristol. My name's James, and I'm one of the data scientists at the Jean Golding Institute. Our job is to connect multidisciplinary experts across the university and beyond, and we do that with a number of work streams and cross-cutting activities. And one of the activities that we do is developing communities, and that's what we're hoping to do today, all throughout Data Week and also in this training session today. So it's coming towards the end of the week now, but we still have lots and lots of activities going on. So I would encourage you, if you enjoyed this event or if you've been to any of the other events, please do check out our website, bristol.ac.uk/Golding, and you can click on our interactive timetable there, and you can see what other events, seminars, workshops, and training events are on. Just to stop to say a big thank you to all of our collaborators and our sponsors for this week, without whom it wouldn't have been possible to put on this great week of training and events for free. Too many to mention there by name, but I will pick out that Mango Solutions, who are delivering the training today, are one of our collaborators there. So thanks very much. And we'd love it if you could stay connected with us and keep the conversation going, especially on social media. So please use the hashtag Bristol Data Week or mention us at JGI Bristol on Twitter. You can follow us on LinkedIn. And if you want to keep in touch with what's going on with data science at the University of Bristol, then if you go to our website, you can subscribe to our newsletter. There's also some other great links in the chat that Elaine has put in now, including our data ethics club that's meets every 2 weeks, and they've got some great sessions. So finally, a plug for our next event, which is the Jean Golding Institute Showcase, which will take place in February next year at the iconic M-Shed building on the harbour side. It's a family-friendly event, open to the public, and there'll be some inspiring speakers, exhibitions, and also a chance to meet people and network, hopefully COVID allowing. So we're really looking forward to that and hope that you'll be able to make that event too. So that's my introduction finished, and the next thing for me to do is to introduce our 2 great trainers for today for Introduction to Shiny App Building in R from Mango Solutions. Firstly, we have Elizabeth Brown. Elizabeth is a professional placement student at Mango Solutions, currently studying mathematics and statistics at the University of Bath. She has an interest in all things data science. As well as working on projects, she has delivered training, workshops, and presentations, including at the London R and Barcelona R conferences this May. And she also enjoys developing Shiny apps in R, having developed a production-grade Shiny learning tool as one of her projects. And we also have Jack Talboys. Jack is a data scientist at Mango Solutions. Having started there as a placement student whilst completing his degree in statistics, he later joined the company full-time after graduating. He has expertise in software development, including version control, testing, and issue tracking, which are all things that are very important when you actually get developing software for real. And also, he also delivers training courses for Mango. So without further ado, take it away. Thank you very much.
Thanks, James. Hi, everyone. Welcome to the workshop. So first to say that any questions throughout the workshop, if you just put them in the Zoom chat, and Jack will try to answer, and I will also answer any questions throughout as well. You should all have received materials for the workshop, so you should have a PDF and then 2 R scripts, one which is called dashboard template and the other one which is called code for dashboard. So if you don't have these 2 scripts, can you please say this in the Zoom chat and we'll sort this out. It should have been provided with the on Eventbrite. So today the workshop, how the layout for the workshop is that we're going to start by looking at input and outputs within Shiny apps. We're going to look at a bit of reactivity and UI layout. And then at the end, we're going to have the opportunity to create your own dashboard. So I'm going to start by sharing my screen. So what actually is Shiny? So Shiny is a free open source R package, which is actually developed and maintained by RStudio, and it allows us to develop interactive web applications directly within R. So it's a great way to be able to visualize any data analysis or models, and as well for users who maybe don't have any knowledge of the R language. It also allows us to create apps quite quickly and easily without needing to know knowledge of things like HTML and JavaScript. So this website here provides a gallery of different types of apps. So it gives different examples of dashboards and Shiny apps for all different use cases. So if we actually go into R and open up a script, we can actually load in our package. So you should have already done this already, but if not, that's okay. To install the Shiny package, you want to run install.packages of Shiny. We're also going to use another package today called Shiny Dashboard. So to install that, you need to run install.packages of Shiny Dashboard. Additionally, we're going to use a package that many of you might have seen already from data analysis in R, and that's called the tidyverse. So first we're going to load in the Shiny package itself. So this package provides a function called run example. And if we run this, it provides a list of different example apps which are already provided to us from Shiny. So let's have a look at the 4th example. So if I do run example 04 MPG, this will then bring up a window, and this is a Shiny app. So I can expand this app to be my full screen. And here we can see we have some input widgets, so the user can choose from a drop-down list and also check a checkbox. And then on the right, we have this plot displayed. So I could choose transmission and then the plot will change. These example plots, these example Shiny apps also provide the code that goes into creating the apps. There's also a button up on the top left which says open in browser. So if we click this, it will actually open the app in a browser as well. To close the app, we can do this in a couple of ways. So we can close this window and this will stop the app from launching. Or in the console in our studio, there is a button to the top right which is red and says stop. So we can click this and this will stop the app from running. And as you can see, we now have our R prompt back in the console. So we've seen an example of an app. So let's actually start looking at building one for ourselves. So a Shiny app is made of two components. One is the UI and the other is the server. So the UI describes the appearance of the app. So that's what the user sees and interacts with. The server, it contains all the app logic. So that sits behind the scenes. So first we're going to have a look at these widgets or elements. So in our UI, we define our widgets. So these could be buttons, tables, plots, and we give these unique IDs. So these will become important shortly. So first, let's just have a look at the two different components. So we can create our UI component by using the Shiny function fluid page. So this is our UI component, and in here we will provide different widgets and anything that the user will see. We then set our server. So this is a function that we define ourselves. So we use the function and give it the arguments input and output, and then use curly brackets. And in the curly brackets, we will provide the app logic. Now we have our two components. To launch the app, we use the function Shiny app. And here we give it our UI and our server. So we can run each individual lines like so, and this will bring up my Shiny app. Here it's blank. We haven't given anything in for the UI or the server. And additionally, I can run this in a file by itself. So if I create a R script and copy over this code into my R script, at the top, I'm going to library in the package Shiny and then paste this code. I can then save the file as app.r. So here I have my R script with my app code and it's saved as app.r. Notice that RStudio has provided a run app button. So if I click this, it will run all of the code in that file and launch my app. So this becomes useful when our app code becomes longer and we don't want to have to run each individual line. So we'll see that again later on, but for now I'm just going to work in a script and run the lines individually. So I previously just mentioned about UI widgets. So these are buttons, tables, plots, and we define these in the UI. So there are a number of different inputs that we can provide. So we can provide drop-down lists, sliders, checkboxes, and these inputs are what we want the user to interact with. So we want the user to be able to click a button or choose an option from a drop-down list. So we're going to have a look at a couple of examples of different types of inputs. So the first, we're going to look at a drop-down list. So first I'm going to create my UI component. So I'm going to use the function fluid page. And in here, I'm going to define a drop-down list input. So to do this, I'm going to use the function select input. And the first argument I give is the input ID. So this ID is important, and we'll see why shortly. And this input ID has to be unique for each different widget. So here I'm going to call it select. You can give it any ID you like. I'm then going to provide a label for my drop-down box using the label argument. And then using the choices argument, I'm going to give it the choices that I want to appear in my drop-down list. So I provide these choices in a vector. So now I've defined my UI. I then want to create my server component. So I'm going to create a function that has an input and output as arguments. And for now, I'm not going to add any app logic. This is just going to be left blank. And then finally, I'm going to launch the app using the function Shiny app. So if I run each line of code, our app appears, and you can see we have a drop-down list. So it has the label, which I specified in the widget, select from drop-down list, and then we have each choice that I gave it. So the user can choose, click through these choices. Let's have a look at another type of input. So this we're going to look at a slider input. So this works in pretty much the same way. So we're going to define it in our UI component. So to create a slider input, we're going to use the function slider input. And the first argument is our input ID. So I'm going to call this widget slider. I'm then going to give it a label. And then I can set a minimum and maximum value for my slider. So I can say min equals 2 and max equals 15. I can then give an initial value for the slider. So when the app opens, this will provide the location, the initial location of the slider. And again, I'm going to set my server component to be a function with an input output arguments. And then I'm going to launch the app using the Shiny app function. So here we have our app launched, and we have a slider input widget. So it has the label move slider. Our minimum value is 2, our maximum value is 15, and then the initial value is 7. And the user can drag this slider along like so. So there are a number of different inputs that we can provide, and in a similar way, we can provide output widgets. So these are things that we want to display in the app. So this could be a plot, an image, a table. And in the same way as for an input widget, we have an input ID. For an output widget, we have an output ID.
Sorry, Elizabeth, could you just zoom in one, please?
Oh, zoom in, yeah. Is that better?
Looks better to me, thank you.
Cool. So let's first have a look at a table output. So we're going to create a UI component again using fluid page function. And then we're going to provide a table output. So to do this, we're going to use the function table output. And we give it an output ID. So here I'm going to call it table. Now we've set an output widget, but we haven't actually told the widget what we would actually like to display. So here it knows that we want to display a table, but it doesn't know what data we actually want to display in the table. So to do this, we use the server function. So we're going to create our server, which is a function with an input and output arguments. And then in our server component, we are going to render this table. So the first thing we're going to do is tell the server that we want to look at this output widget. So this is where the output ID becomes important. So I'm going to say output $table. And what this does is looks for all the output widgets in my UI and finds the one that has the unique ID table. I'm then going to assign this to the function render table. So here is where I then provide the code for my table, and this function will render that code and render it into the relevant widget. Because I'm using a table, I use the render table function, and inside here I'm going to give it the data empty cars. And then again, I will use the function shiny app to launch the app. So here we have shiny app, which has a data table output, and we can see the empty cars data set. You can also look at a similar example, but now for a plot. So this works in pretty much the same way. So first we create our UI component using the function fluid page. And in here, we want to create a plot output. So we're going to use the function plot output and give it an output ID. And then in the server, I'm going to render the plot. So I create my server using creating it by defining a function with arguments input and output. And then in my server, I'm first going to link the server with this output ID. So I'm going to say output $plot, and then I'm going to assign this to the output of the function render plot. And inside here, I'm going to provide the code which will actually create the plot. So here I'm going to plot the MPG against the displacement from the empty cars data set. Finally, I will use the function shiny app to launch the app. So here we can see in our shiny app, we have the plot displayed. So in the materials, there is a table on page 10, which provides different types of output and then the relevant UI function, server function. So we've seen a table, so we want a table output, and then in the server, we use render table to render the table. Similarly, we've seen plot output, and it works for images and text as well as a different type of data table output. Does anyone have any questions so far? I'll open the chat. So I'll just quickly go over how to launch the app again. So when we create first we need to load in the Shiny package. So we do this by running library Shiny. So you just need to load this at the start of today. Then to actually run the code, we run our server. So to do this, I'm using Control Enter, or you can select and click the run button. I'm then running my server component. So here I have my UI and my server defined. And then to launch the app, I'm running the function Shiny app of the UI and the server. So when I run this, the Shiny app launches. Okay, Alexa, Jack will come and help with your issue in the chat box. It might be something else going on. So I'll just continue with the workshop and then hopefully that gets resolved. Okay, so we've had a look at inputs and outputs. So normally in our Shiny apps or in sort of any app, we want the user to be able to interact with the app and then that action actually do something in the app. So for example, the user clicks a button and then something appears. The user chooses from a drop-down list and then that changes something, for example, with data or a plot that's been displayed. So to link our inputs to our outputs, we use our input IDs. So let's have a look at an example of an app where the user picks from a drop-down list a column name, and then that column is selected from data frame and displayed in the app. So to do this, I'm going to library in the tidyverse, and I'm going to use a function from the tidyverse called select. So I've just loaded in the tidyverse, and then I'm going to create my app. So first, I'm going to create the UI component using the function fluid page. And I'm going to specify, firstly, an input widget. So I'm going to use the function select input to create a drop-down list. And then I'm going to give it my input ID. So I want to call it select. And then going to give it a label. And then I'm going to give it the choices for the drop-down list using the choices argument. So here I'm going to give it 3 different columns from the empty cars dataset. Next, I'm going to define my output widget. So I'm going to place a comma there and then create my table output using table output and then giving my table ID. Next, I'm going to create my server component. So the server is going to be a function that takes an input and an output. And in here, I need to render my table. So just like before, I'm going to link this output widget with my server using output$table. And I'm going to use the function render table to actually render the output. So for the code to actually render this, I'm going to use the function select from the tidyverse. So this function takes some data, so empty cars, and then takes the name of a column to select. Now here in my app, I want the user to be able to choose the column. And so in order to link my input with the output that's being rendered, I say input$select. So what this will do, it will look for any input widgets in my UI and find the one with the unique ID select. And then it will then find the choice that the user gives, and then it will select from the empty cars that column and then render the table to the table output widget. So if I run the app using Shiny app, we can have a look at this interaction. So here we have our drop-down box followed by some data, and this is the MPG column. So I can go to the drop-down list and click HP. And now my HP column has been selected. And again, DISP, the displacement column has been selected. So let's have a look at another example. It will work in pretty much the same way. Now looking at controlling a plot. So I'm going to create an app which displays a histogram of a given number of random samples of a Poisson distribution. I want the user to be able to interact with the slider, and that slider determine the number of samples that are taken. So first I'm going to create my UI component using the function fluid page. And I'm going to first specify my slider widget. So I'm going to use slider input and give it my input ID. Going to provide a label. The minimum value for the slider and the maximum value for the slider and the initial value. I can also use an argument called step, and this allows me to specify the steps in which the slider is broken up into. So then I'm going to use a comma and next specify my plot output widget using plot output. So I give it the plot output ID and I'm going to call it plot. So next I'm create my server component, which is a function that takes arguments input and output. And in here, I'm going to render my plot. So I'm going to say output$plot to link with my plot output. And I want to assign this to the function render plot. And in here, I'm going to provide the code which creates my histogram. So I'm going to do create a histogram of random samples of the Poisson distribution. So to get my random samples, I use a function called rPos. So in here, I'm going to give it my number of random samples, so n, and also my lambda value. So in this case, I'm going to take random samples from a lambda 5 distribution. So I want in my app the user to determine what the random sample is by using a slider. So essentially the slider input is going to specify what this n value here is. And to link my output widget with the input widget, I'm going to say input $slider. So this will look for from my input widgets, find the one that's called slider, and then take that input and find that number of random samples of the distribution. So finally, I can launch the app. So if I run each part, run my UI, server, and then Shiny app, my app will launch. And here we have a input slider followed by a plot. And the user can move this slider and it will change the histogram like so. So that's how we link up output and input widgets. Does anyone have any questions? Okay, so we're going to have a short break and I will just run through a recap of the materials so far for those who've joined a bit later on, and then we'll continue with the rest of the workshop. So I'm just going to go through the code now, but by all means go away and have a break if you don't want to have a recap. So, oh, there's a question. Yes, so you need to have the UI and a server. Okay, so Shiny is a open source package which we can install via install.packages. So you can run this if you haven't already. I'll paste that in the chat as well. And the way that a Shiny app is built is it has a UI and a server component. So the UI controls the appearance and the server controls the logic. And then we use the function Shiny app to launch the app. So this takes our UI and our server and launches it. So if I run these 3 lines of code, my Shiny app will launch. And in this example, the app is blank, so I haven't specified anything in my UI or my server. To close the app, I can either just close the window off like so, or I can click the red stop button in my console. So in our UI, we can specify input and output widgets. So these are things that either the user interacts with or sees. So any input widgets, the functions tend to look like sort of select and then input. So here we are defining a drop-down box. So each input and output ID have a input and output widget, have an ID, and this is unique. And then we can link them together through these IDs. So if I just go over the 2 examples of linking them together quickly. So for this example, in my UI component, I have a drop-down box and then a table output. And then in my server, I'm going to render this table based upon the input that's provided. So here it will look for all of my output widgets in my UI and find the one that's called table. And then here I'm going to use the function render table to actually render the data. So in this example, I'm using the select function to select from the empty cars dataset a column. Now this column is specified by the user through selecting from a drop-down list. So to access this choice, we first find all of the input widgets and find the one that's called select, and then it will take the option and select that column. So similarly, just what we've just looked at, here I have a slider input. So this provides a slider widget, and then we have a plot output. So here I'm finding the output widget called plot, and then I'm rendering my plot. And in here, the number of random samples for this plot is determined by the input from the slider. Great. So the next thing we're going to have a look at is an action button. So action buttons are inputs. The user interacts with an action button, but they behave in a slightly different way, because when we click an action button, we want it to trigger something to happen. So it's as if we are observing the event that the action button has been clicked. So let's have a look at an example. So first, I'm going to create my UI component using Fluid Page. Although I hope everyone's back from taking a break. So in my Fluid Page, I'm going to specify an action button and a plot output. And for this app, I want the user to click the action button and then the plot will appear. So I'm going to use the function action button to specify that I want the button. And in here, I'm going to give an input ID as before, and I'm going to call this button. And then I'm also going to give my button a label. Then I give a comma, and next my plot output widget. And in here, I give my output ID. Next, I'm going to create a server component, which is a function that takes arguments input and output. And in here, I'm going to specify the logic behind the app. So for this app, the user is going to click a button and then the plot will appear. So to do this, we use a function called observe event. And essentially, we are observing the event that the button has been clicked. So our first argument is input $button. And then the second argument is the code that we want to run. So the sort of server code that we've already looked at so far. So observing the event that the button has been pressed, we want to render our plot. So I'm going to say output $plot, assign this to render plot. And then in here, I'm going to provide the code to create a plot. So I'm going to use ggplot for this from the tidyverse. So I can pipe the cars dataset into ggplot and plot speed against distance, like so. And then finally, I'm going to use the function run app to launch the app. So I'm going to run each individual part and then the app. So we can see that we have this button here called Produce Plot. So when the user clicks the button, the plot appears. So in the materials on page 15, there is an exercise which gets you to create a simple Shiny app step by step. So first, you want to create a Shiny app that displays a plot, and you can use this code here to actually create the plot in the server. And then it asks another 2 questions about connecting up some inputs and outputs. So I'll give you 10 minutes to do that. Also, when using this code here, you need to load in the tidyverse package. If you haven't installed this package, I will just put this in the chat. Just run install.packages of the tidyverse. There's no requirement to sort of understand what the code is doing necessarily, but it helps if you have seen it before. So I'll give you 10 minutes to do that. Hi everyone. Okay, hope everyone found that exercise okay. So I'm going to go through the answer to it now. So the first question asks to create a simple, shiny app that displays a plot using the following code. So just add a header there. So the first part of our app is the UI component. So I'm going to create my UI component using the function fluid page. And in here, I'm going to specify a plot output widget. And then within this, my output ID. And then next thing I'm going to do is create my server component. So this will be a function with arguments input and output. And in here, I'm going to render the plot. So to do this, I'm going to say output $plot and assign this to function render plot. And then in here, I'm going to copy and paste the code from the exercise, like so. And then to run this, I use the function shiny app. So if I run these two components and then shiny app, it will create my app and display a plot. So the second question says using the SE argument in geom smooth, so this argument here, create a checkbox that determines whether or not the confidence interval is displayed in the plot. So I'm going to just copy this code and then edit the code for this second part. So before the plot, I want to have a checkbox. So I'm going to do this using the function checkbox input. And I'm going to give it my input ID. So I'll call it checkbox. And then I'll give it a label. Like so. And then after this function, I need to give a comma for the next function here. So I have my checkbox and my plot output. Now in my server, I'm still rendering the same plot, but I now want to change this argument to link it with my checkbox input. So instead of equal to true, this is going to be equal to input $checkbox. So if I run my UI server and then shiny app to launch the app, I now have my plot. And if I click the checkbox, this confidence interval will appear on my plot. And I can uncheck it and it will disappear. And then the third part of the question asks, using the color argument, create a drop-down box which allows the user to select a color for the line. So I'm just going to take this code again and then add to it. So here I'm going to add a drop-down box after my checkbox. So to do this, I'm going to use the function select input and give it my input ID. I'm going to call this color. I'm then going to set a label. And then I'm going to give it the choices. So these are going to be some different colors. So I could say blue, purple, and orange. And then at the end, add a comma. And now in my server, I want this color argument here to be determined by my drop-down box. So instead of being equal to blue, this is going to be equal to input $color. So if I run each part, my UI, server, and shiny app, I now have two input widgets, a checkbox for my confidence interval and a drop-down box. Say I click purple, the line on my graph is now purple. Does anyone have any questions about this? Okay, so the next thing that we're going to look at is reactivity. Actually, before this, let's say we'll have a 5-minute break. And if anyone has any questions, you can stick them in the chat. So we'll see you back here at 13 past. Hi everyone, I hope you're all back and had a nice break. So next we're going to look at reactivity. So far we have seen how we can have output and input elements and we can connect these together. So these connections are also known as sort of dependencies, and Shiny controls these through something called reactivity. Essentially, the more elements we get, the bigger the app gets. These dependencies are going to become more complex, and Shiny takes care of these for us. But what we can actually control this reactivity for a number of different reasons within our Shiny app. So we're going to look at a couple of examples of actually being able to control this reactivity. So first, I'm just going to show you an example from earlier.
Please, could you quickly redefine dependency again?
Yes, so here if we have a look at this app, so we have our slider input, which is determining the output that's been rendered. So essentially there is a dependency. So this plot here is dependent upon the input that is being given. So this is one dependency. So as our apps get bigger, you can imagine that these dependencies sort of become greater in numbers and a bit more complicated. So this output is dependent upon the input.
Thanks.
No worries. So Shiny controls this using reactivity. So if we have a look at this example, here we've specified the value of the input within our render plot function. So say instead we slightly change the server, and instead of having this inside here, we have it outside. So let's create a object called n, which is our input. And then we can put n in here. And that sort of seems like it would work. But if we run this, it will actually error. So if we try and launch the app, we get an error here in the console. And part of the error says you tried to do something that can only be done from inside a reactive expression. So this here, this render plot function, is a reactive expression. So Shiny, in order to control these dependencies, requires that this input here is within this render plot function. So we can't do something like this. So we can actually control this dependency for a number of reasons. So say we had multiple different outputs that all depend on one input. We can use reactivity to sort of shorten our code in the server. And say we wanted to delay any updates to our outputs, we can also use reactivity to do this. So we're going to have a look at a couple of examples of this. So the first example I'm going to look at is multiple outputs with one input. So I'm going to create an app which displays a histogram of the Poisson distribution like before, and it's also going to show a summary of the random samples of the distribution as well. So I set my UI component. So UI is fluid page, and in here I'm going to specify my widgets. So I'm going to create a slider, give it my input ID, give it a label, minimum, max, and a value, just like before. Then I'm going to specify the plot output and give it output ID plot. And then after this, I'm going to see a summary of the data. So I'm going to use a function called verbatim text output. So this will output text which looks like it's been printed to the console. And then I'll give this a ID summary. Now in my server is where I'm going to control the reactivity. So I'm going to create a function that has arguments input and output. And in here, what I want to do is render the plot and the summary, but they're both dependent on the same input. So I could do what I've done before and render each one and call the input in each render, or I could actually do something called creating a reactive expression. So I'm going to say get samples. This is the name of my reactive expression that I'm creating, and I'm going to create it using a function called reactive. And then in here, I'm going to put the code rpros input slider and then 5. So what this will do is take my input and find the random samples. Now I can do this because it's within a reactive expression. So this function, reactive, is creating a reactive expression. So now, instead of calling this in every single output render, I can instead just call this function here, this reactive expression. So I'm going to say output plot. Now I'm going to render my plot. So I'm going to render a histogram, and then inside this function, I'm going to say get sample open and close brackets. And what this does is calls this reactive expression. And then I can do the same, but for my summary. So to render this, I'm going to use the function render print. And then I want to create a summary of the random samples. So here I'm going to call my reactive expression. Here you can see that now I've only had to call this input here once, and I have this reactive expression. So you could imagine if I had more than 2 outputs, this makes the code a lot easier to manage. So let's actually launch the app. So I'm going to run my UI, run my UI, run the server, and then launch the app. So now we have a slider, a histogram, and then a summary. So if I change the slider, it changes the histogram and the summary. So both of these are dependent upon this input here. So we can look at a different example of controlling reactivity. So for this, we're going to look at delaying output. So for this, I'm going to create an app which displays a plot, and there's going to be a button which the user will have to press in order to update the color of the points on the plot. So first, I'm going to create my UI component. So I'm going to have a select input, give it my ID, give it a label, and then give it my choices. So these are the colors for the points. I then want an action button. So I give it an ID and then a label. And then I want a plot output. So to control the reactivity, so to delay this output, I'm going to do this using the server component. So I'm going to create a function with arguments input and output. And then first I'm going to create a reactive expression, but this time I'm going to use a function called event reactive. And this is because I'm using a button. So I'm going to essentially create a reactive expression and the event that the button has been clicked. So I'm going to call it update color. And I'm going to use the function event reactive. And the first argument here is going to be the button. So input $update. So in the event that the button is being clicked, I'm going to create this reactive expression. And in here, I'm going to give it input $select. And then I can render my plot as before. So here I'm going to use the base R plot function and plot MPG against this from the empty cars dataset. And I'm going to use the color argument to specify the color of the points. And I'm going to make this equal to update underscore color open and close brackets. So here I'm calling this reactive expression. And finally, I'm going to run the app. So I will run the UI, the server, and then launch the app. So here we have a drop-down list to choose a color. And then when we click update, the plot appears with blue points. Say I want to change the color and go to my checkbox and click red. But the plot actually hasn't changed, even though I've selected red in my checkbox, in my drop-down list. To actually update the plot, I'm then going to click the update button. So when I click this, now my plot is updated with this color. Does anyone have any questions they'd like to put in the chat? And mine's 285. Okay, I'll just go through. So someone's asked a question about going through this part of the server. So here, this function event reactive is going to essentially observe the event that this button has been clicked. And when the button's been clicked, it's going to create a reactive expression and going to take my input from the drop-down box. So then when I render the plot, I'll call this reactive expression, but this reactive expression won't be initialized until that button has been clicked. So when the button has been clicked, this reactive expression will then actually return the selection from the drop-down box. So then the plot will actually be updated and render. This isn't a shiny question, but I'll answer it anyway. This is the same as saying X is MPG and the Y is the displacement. It's a formula notation that you can use in R. And I will scroll up to the first example, but there is a exercise on page 23 of the notes. So it's the end of chapter 4. And it's just a quick fill in the gaps exercise just to get your head around sort of what a reactive expression looks like in the server. So I will give you about 5 minutes to do this, but I will scroll up to that first example here. Exercise. There we go. This example. Yeah, brilliant. Okay, I'll give you about 5 minutes to do this. So come back at 33 past. Hi everyone, welcome back. I hope you all have had a nice break there. Do the exercise. So let's have a look at the solution. So I'm just going to copy over the code from the exercise with the gaps in to fill. So we have a server component, which has a text input, an action button, and a plot. And then in our server, we want to delay the output. So we want the user to be able to provide a title and then click the update action button to then update the title of the plot. So to do this, I'm going to use the function event reactive. And my first argument will be the button being clicked. So input $update. And then inside my event reactive, I'm going to give it the input $title. So when the button's clicked, it will get the title that's been inputted, and then I'm going to call this reactive expression within my rendering of the plot. So here I'm going to say update underscore title open and close brackets. So if I run this, you can see our app. We can give the plot a title and then click update. It will create my plot with a plot title, and I could change it again. Click update, and then the plot title will change. So before we move on, I'm aware that there's people who have been joining late. So I just want to give a sort of quick summary of what we've just done so far. And just want to reiterate that all the code that's written today, you will get at the end of the workshop. And also the workshop is being recorded. So what we've looked at so far is how to firstly launch a Shiny app. So Shiny app has two components, our UI component and our server component. And then we launch the app using the function Shiny app. In our UI, we specify what widgets we would like. So we could have input widgets and output widgets. Input widgets are what the user interacts with. So here the user can input some text. And then we have functions that end in output for our outputs. Then inside of our server component, contains all of the app logic. So this is the code that actually renders our outputs and provides the actual code for, say, plots and data tables. So here we access our widgets via the dollar symbol. So here we're finding from all our input widgets, the input that has the unique input ID title. And then we can do the same with our output widgets. So take from all the output widgets, the one that's called plot. And then we've just had a look at some basic reactivity as well. So the next thing we're going to look at is UI layout. So far we've been focused on the server, and someone noticed in the chat earlier that when we've been looking at these apps, the widgets have been appearing in the order specified in Fluid Page. So there are a number of ways that we can control the layout. And in the materials that are provided, the PDF, there are a number of different examples of different ways that we can lay out our widgets. So in this workshop, we're just going to cover one of those examples, but there are other examples there for you to look at in your own time and to just have a play around with the layout of your apps. So in this workshop, we're going to have a look at a sidebar layout. So let's just take an app. So I'm going to create a UI just like I did before using fluid page. And I'm just going to copy in some input widgets just to save some time. So here we have 3 input widgets. So these are 3 different drop-down boxes, and they are each for the user to select different colors for a plot. So here I need to give my choices. So I can give some other colors like green, pink, gray, and orange. And then I'm going to provide a plot output. So using the plot output function. And then I'm going to give it a ID. So this is just in the same sort of way that we've been looking already. We're just using this fluid page, and these inputs will appear, these widgets will appear in the order that's been specified. And then we create our server. So here I'm going to create a function with arguments, input and output. I'm going to render my plot using output $plot and the function render plot. And then in here, I'm going to provide some code for my plot. So I'm just going to copy this in. This uses ggplot. Like so. Okay, so here we have linked our colors with our inputs. So here we're taking the values from the first, second, and third drop-down boxes. So we just have a quick look at what this looks like. Just run this app. You can see we have these 3 drop-down lists and then our plot, and we can choose the different colors for our legend here, like so. So in our UI layout, we have the widgets specified in the order that we've provided. So instead, what we're going to look at is a sidebar layout. So what we'd really like is for these widgets here to be in a sidebar to the left, and then our plot to be on the right. So we can do this using a function called sidebar layout, and then within this we use functions sidebar panel and main panel. So the UI becomes quite nested in its functions. So we're going to have a look at how we build this up from this UI here. Just to note that we're changing the arrangement of the widgets on the app, but we're not actually changing any of the logic with the app. So we don't need to do anything with the server. So I'm going to create a UI using Fluid Page. And instead, in here, I'm going to give the function sidebar layout. And this takes 2 arguments. So my sidebar layout has a sidebar panel and a main panel. So first I'm going to look at the sidebar panel. And to specify this, I'm going to use the function sidebar panel. And in here, I'm just going to list my inputs. So here, I just want my 3 input widgets. Then after my sidebar panel argument, I'm going to place a comma and then use the main panel argument and make this equal to the main panel function. And in here, I want my plot. So I want my plot to be on the right-hand side in the main panel. So now if I run this UI, and then I already have my server specified, so I can just run Shiny app. If we have a look, now we have this left-hand sidebar here with the inputs, and then on the right, we have a output of our plot. So this is one way that we can control the layout. So when we're controlling the layout, we don't touch the server. It's all to do with the UI. So there's actually a package that we're going to use called Shiny Dashboard, which allows us to create dashboards. So Shiny can be used to create a dashboard, but it's actually using the Shiny Dashboard allows us to create attractive dashboards quite quickly and easily. And it also provides functionality on top of Shiny. So we can use everything that we've learned so far and the Shiny Dashboard package. And the Shiny Dashboard works in the same way as an app. So we have our UI component and a server component. The only thing that's different is how the UI is laid out. So for a dashboard, we define our UI to be the function dashboard page. And I'm just going to actually load in the package. So I'm going to do library of Shiny Dashboard. So my UI is defined by the Shiny Dashboard function. And in here, we have 3 parts to the dashboard, which we have to provide. So first, we have our header. So we provide this using the Shiny Dashboard header function. Next, we have a sidebar. So we specify this using the Shiny Dashboard sidebar function. And then we have the main body. So we use dashboard body for this. Then we define our server in the same way as we have been. So we can create a function with arguments input and output. And for now, I'm just going to keep this blank. And then I can run the app in the same way using Shiny app and give it my UI and my server. So if I run this, I will get a blank dashboard. So here we have a blank dashboard. We have this sidebar to the left and then a main panel or body of the dashboard to the right. Then we can also provide a header in this top left corner. There's also this button which allows us to hide the sidebar as well. So what we're going to do is take the code that we've just written, creating a sidebar layout in Shiny, and convert this into a Shiny dashboard. So let's just copy our code from before. So let's just hide that. So here we have our UI from before with our sidebar layout. And then we have our server, which controls the logic, and then we can run the app. So now I'm going to keep the server as it is, and I'm going to change the UI. So instead of using this fluid page, I'm going to create a dashboard. So first, I'm going to say to use the dashboard page function. And the first thing I'm going to do is provide a header for my dashboard. So I do this using the dashboard header function. And in here, I can give a title for my dashboard. So I can call it My Dashboard. Then I use a comma, and next I'm going to specify the sidebar. So I use the function dashboard sidebar. And in here, I'm just going to list out my input widgets. So in Shiny Dashboard, instead of using this sidebar layout and then sidebar panel and main panel, this is essentially taken care of with the format of the dashboard. So then I'm going to use the function dashboard body to specify that I want my plot to appear in the main part of the dashboard, like so. So now if I run these two components, I get my dashboard, and here you can see I have the title for my dashboard. I have my input widgets on the left-hand side sidebar, which I can hide. The logic still works. I can still select different colors. And my plot is here in the main body of the dashboard. So in the PDF materials, there are a number of examples of taking different UI layouts made in Shiny and transforming them into dashboard layouts. We can also use the layout functions from Shiny within our dashboard functionality as well. So everything that we've learned so far, all of the Shiny functionality we can use with Shiny Dashboard. So there is an exercise on page 46, which asks you to take this app here and change the UI so it is a dashboard using the package Shiny Dashboard. There's also an extra part which asks you to display the plot within a box. So don't worry if you can't do this. I will show you how to do that. But if you have time, have a little dig around and see if you can work that out. Remember to library in the Shiny Dashboard package before you start. So I'll give you 10 minutes to do this, and then we'll go through the answers. If anyone has any questions, just pop them in the chat box. Someone's asked, is Shiny Dashboard responsive so that it works well on small screens? I'm not sure in terms of phones, but say I run this dashboard again, I can keep it in this small window here. And if I want to see the sidebar, I can open the sidebar up like this. So I would assume that you would be able to load it up in a small screen. Welcome back. Let's have a look at the solution to that exercise. So I'm going to copy over the app from the exercise. So here we have our UI. It has a drop-down list, an action button and a plot, and then has a server. And the color of the plot is updated with the update button. So we've seen this example already. So what we're going to do is transform this into a dashboard. So all I'm going to change is the UI component. So let's change this UI. So I'm going to use the function dashboard page. First, I'm going to give a title for my dashboard using the dashboard header function. So I'm going to call this my dashboard. Next, I'm going to specify the sidebar. So I'm going to use the function dashboard sidebar. And in here, I'm just going to list my two widgets. So I want my drop-down box and my action button. And then I'm going to use the function dashboard body to specify my plot output. So if I run this and then run the server and launch the app, you can have a look and see that we have the drop-down box and a button. If we click update, the plot will appear and the points will be blue, and then we can change the color of these points. The extra part of the exercise asked if you could display this plot within a box. So we can do this using the function box. So we can wrap this widget inside of a function called box. So let's remove that and say box. We need to give it the width. So the maximum width is 12, which I'll explain in a second, and then give it the output widget. So if I run this instead and then launch my app, can now see that we have this box here and the plot is produced within this box. So the width for this box has a maximum value of 12, and this means essentially the full width of the page. So when we had a look at the dashboard, here the full width of the body is 12, so denoted 12. And if we hide the sidebar, it's now reaching for the whole width of the dashboard. So if we set it to be width equals 6, then it would stretch to be half the to cover half of the dashboard. If anyone has any questions, pop them in the chat. And what we're going to do is have a 5-minute break. And then after that, we're going to actually create our own dashboard using some template code that you should all have. Let me know if you don't have these two files, the dashboard_template file and the code for dashboard file. We're going to use those and create our own dashboard. So let's have a 5-minute break and then we'll come back with fresh eyes. So see you in 5. Welcome back, everyone. Hope everyone had a nice break. So now we're going to create our own dashboard. So you should all have the two R files. They might be called script underscore code for dashboard and script underscore dashboard template. That's fine. So let's open up these two scripts. So one script contains a template for a dashboard. So I'm just going to run this script by clicking the function, the button here, run app. So what we can see is we have a sort of template dashboard that we can fill out. So we have a title and we have 3 different pages. Now currently they have boxes which don't have anything in. And what we're going to do is fill in these pages with relevant information and widgets, etc. And the purpose of this is to let you have a play around with different inputs and outputs and be a bit creative and have fun with it. So the idea is that this dashboard is going to have 3 pages. First page to display a plot, the second to display a summary and prediction from a linear model, and the third to display the data that was used. So in the file code for dashboard, there is some code for each page, and this is the code that we'll put in our server. So don't worry about needing to know how to create plots and models, etc. We're just focusing on the dashboard itself. So you can copy in this code in the relevant places when we get to it to create the plots, models, and predictions. So we're going to do it in sort of 3 stages as if it was 3 separate exercises. So we're going to look at page 1 first. So if we scroll down, we can just have a look and see our template. So you can insert a header for your dashboard, and then you can change the titles for the pages. Then there's a section that says create pages, and there's a section for page 1. So what we're going to do is display a plot and also any inputs that you like. So if you create a plot output and then in the server render that plot using the code from the code for dashboard script. As well as that, if you want to, it's totally optional. You can add some input widgets and connect them up like we have done previously in the workshop to control the plot in different ways. So it's up to you how you want to do it, have a play around. So I'll give you about 10 minutes to do this first page, to have a play around, and when you want to run the app, the quickest way is to click the Run App button in the RStudio interface. So drop any questions or issues in the chat, and in 10 minutes I'll show you a sort of model solution. So one sort of solution for this page. And yeah, so I'll give you 10 minutes to do that. Okay, let's have a look at a possible solution for this first page. So I can start off by setting a title for my dashboard. So I'm going to call it Modeling Ozone. You could call it whatever you like. And then I'm going to give a title for my first page here. So I'm just going to change this to Initial Plot, like so. Then I'm just going to scroll down to this Create Pages section and then just go to page 1. So for this, I'm going to add a plot output here. So I'm just going to do the output first. So I just need a comma after the width in my box function. And then I'm going to add in a plot output widget and then give it a ID of plot. Then I'm going to scroll down to the server component here, and this is where I'm going to render that plot. So I'm going to say output $plot. So that's looking for my plot widget. And then I'm going to render the plot. And in here, I'm just going to paste the code from the code for dashboard file. So I'm just going to take this and copy and paste it into here. So now if I run this, it will create a dashboard. And on the first page in my second box, I have my plot. So now what I'm going to do is I'm going to add a input. So you could have added any inputs you like. So I'm going to add a text input. So here in this first box, I'm just going to add a comma, and then after the add any input widgets comment, I'm going to add a text input. I'm going to give it the ID plot underscore title. So I'm going to do is allow the user to select the title for the plot. And then I'll give it a label as well. Now I'm going to go back down to my server. And here, instead of having plot title, I'm going to change this to be input $plot title. So now my plot title in my plot will change depending on that input. So if I save the file and then click Run App, have a look, we have our header, our page title, and now we have this input here. So I can type temp versus ozone, and my title appears here. So that's the first page. Let me know in the chat if you chose any other inputs, if there was any other sort of things people tried out with controlling the plot. So if anyone wants to mention anything that they did, feel free to. And now we're going to do the second page. So if we scroll up, we can set a title for page 2 and then go to the page 2 section here. So for our second page, we're going to display a prediction and summary of a linear model. So in the code for dashboard file under page 2, this is the code that creates a model. So here, this is the model. And then this code creates a prediction, and this code creates a summary. So this code will go into the server. And in our UI, we want to create an output for model prediction and for the summary. Also, you can add some inputs if you want to allow the user to input values for the prediction, but that's something extra they can have a play around with after you've done this. So I'll give you another 10 minutes to try this out and have a play and put any questions you have in the chat, any ideas that you've used as well. Welcome back. So let's have a look at the solution for the second page. So I'm going to scroll back up to the top of my dashboard template, and I'm going to give a title for my page. So I'm going to call this Model and Predictions. Then I'm going to scroll down to my page here, page 2. So I'm going to create an output for my prediction and for my summary. And to do this, I'm going to use the verbatim text output. So my first box, I'll add a comma, and then I'm going to add verbatim text output and give this the ID prediction. And then I'm going to do the same thing, but for the summary. So I'm going to add in here some verbatim text output, then summary. Call that summary. Then I'm going to scroll down to the server and paste in the code from the code for dashboard script. So I'm just going to copy and paste this. Okay. So first I'm going to render the predictions. So I'm going to create my model first, and then I'm going to say output $prediction. And to render this, I'm going to use the function render print. And in here, I'm going to paste in my code for creating the prediction. So here I've created a model called lmod, and then here I'm rendering this output like so. And then next, I'm going to render the output for my summary. So again, I'm going to use render print, and then I'm going to paste in the code to create a summary of my model, like so. So if I run this, we'll get a dashboard. So it has the first page from before, and then my second page is called Model and Predictions, and here I have my prediction and a model summary. So it also said you could add some different inputs. So here it says allow the user to input the values for the prediction. So to do this, I'm going to add a numeric input first. So here I'm going to write numeric input and give it the input ID temp. So this, the user is going to select a number for the temperature value in my model to then create a prediction. So I'm going to set a label. And then I can also set a default value, so the initial value that the prediction is given on. What I'm also going to do is create a drop-down box. So I'm going to do this using select input, and I'm going to call this month. And this will allow the user to select which month they would like to make the prediction on. So I'm going to set a label called select month, and then give it my choices. So here I'm going to give strings 5, 6, 7, and 8 and 9, like so, and then a comma on the end. So now all I need to do is go to my server and link up these two inputs with my output. So if I go down to the server, I'm now going to change the temperature. So the temperature input and the month input for my prediction. So the temperature input, I'm instead going to make this equal to the input $temp. And then for the month, I'm going to do the same thing with the month input. For this, though, I'm going to use a function called as.numeric. This is because my options are strings, so when they select an option, the number 5 is actually a character, and what this does is turns it into a number which can then be fed into the predict function. So if I save this and then run the dashboard and go to my second page, and we can see I have this numeric input, so the user can click these little arrows here or type a number. And notice that the prediction here is changing. I can then also select a month, say I want month 7. It will then change the prediction again. So it will predict the ozone for when the temperature is 78 and the month is the 7th month. So finally, there's a third page, which involves you displaying the data that went into creating the model. So this can be found at the end of Code for Dashboard here. And you just want to fill in the third page to display this data. Also, at the end of the UI component in the template, there's an argument called skin. And this is currently set to be equal to blue. And if you want, you can try some different colors and sort of have a look at the different themes for your dashboard. And again, in the chat function, if people want to put in any ideas, anything that they did in that page, that would be great. And also any problems or issues or questions, add them in the chat box as well. So I'll give you just about 7 minutes to do this last part because it's not that long. And then I'll go through the final dashboard. Welcome back. Let's have a look at the solution for this last part. So I'm going to scroll up and change the title for page 3. So I'm going to call this dataset. And then I'm going to scroll down to my page 3 section here. And in here, I'll add a comma. And then I'm going to add a data table output. So previously, we've just seen a normal data output. I'm actually going to use a function called data table output, which is slightly different. And I'm going to give it the ID data. Then in my server, underneath page 3, I'm going to say output $data and use the function render data table. In here, I'll paste the code in from this file. And then I'm going to save the file and I will run the app. So here I can go down to my third page data set and I have the data that was used to produce the plots and predictions. And this, instead of just showing the data, it's actually a data table, which means that we can interact with it. So we can search for values and we can also sort by the columns. I'm going to show you so it's this app, but with some little extra bits added on. So this is polished up a bit. So here we have a yellow theme. So you could have chosen different colors for your skin. So here the skin argument is set to be yellow. So I could change this to black, purple, green, any of these options here. I've then added a title for my box and some static text. So here it says, using the air quality dataset with missing values removed, this plot shows temperature against ozone, and then I can interact with it in the same way as before. Page 2, I've added some titles and some static text just to let us know that this is a prediction that we're looking at, and this is a model summary. And then again, we have the data set at the end. So to do this, I've used something called Shiny tags. So earlier in the workshop, right at the start, I said that Shiny allows us to create apps without needing to know things like HTML and JavaScript, etc. But we can still use these things within our apps. And Shiny provides functions called HTML or Shiny tags. Essentially allows us to provide HTML. So in here I have used a Shiny tag. So here it essentially allows you to write HTML code. So I've written a header, initial plot, and then I have written some text. So I will send all of the code that I've written today, the solutions and materials, to you, including this page here, so you can have a look at the tags and have a little play around with some of the different features as well. I hope that you've enjoyed the workshop and enjoyed playing around with Shiny Dashboard and sort of creating your own Shiny apps. So that is the end of the workshop. Thank you. I will hand over to James.
Well, just to say, Elizabeth and Jack, thanks very much for taking us through an introduction to Shiny dashboards in R. I think very, very thorough workshop and lots of example material as well. And thanks for sharing the example code and the example sort of tutorial resources as well. So that's really helpful. We will make the recording available on the JGI, the Gene Golding Institute website, and also on YouTube. That will be within the next couple of weeks. So I hope you'll be able to find that useful as well if you want to go and refer back to it. There is a feedback form that we would really value if you could fill in. It helps us improve our feedback, our sessions next time. So the link to that's also been shared just now in the chat by my colleague Elaine. Up next, we have another training course on at 2 p.m. today, which is Introduction to Data Analysis in R, continuing the R theme. So if you're interested in that, that's starting in just over an hour, then there's a link to that that's gone in the chat now as well. And finally, we would really appreciate it if you'd continue to connect with us on Data Week. So if you like this session, then please tweet about it using the hashtag Bristol Data Week and mentioning us at JGI Bristol. And you can also mention Mango as well. And I'm just checking your Twitter handle is at Mango the Cat, I believe. Is that right?
Yeah, that is right.
Great. Okay, but yeah, it just remains for me to say thank you again, Elizabeth, and thank you, Jack, and thank you to my colleague Elaine, who's been putting links in the chat throughout as well. So thank you, everyone, and I hope you enjoyed the session. Thank you.
Yeah, thanks for coming, everyone.
Thanks, everyone.
Yeah. Okay. Thanks, James. Thanks, everyone. See you.
Nice to see lots of thank you messages coming through in the chat as well. So thanks everyone for those.
Thanks, everyone. Bye.
Thanks. Bye.
Yeah.